So let's do some videos using Maclaurin and Taylor series. So here we want to find the Maclaurin series of the function f of x equals e to the x and its radius of convergence. So let's first start off by writing out the Maclaurin series. Okay, so we know that the Maclaurin series is f of x is equal to the sum from n equals 0 to infinity of f, the nth derivative of f, and then we're going to plug in 0 over n factorial x to the power of n. And if I were to expand that, it will be f of 0 plus f prime of 0 over 1 factorial x plus f double prime of 0 over 2 factorial x squared, and then continues on. All right, so now what we're going to be doing, we want to find this part. So this is the part that we want to be able to figure out. So because we have a Maclaurin series, we're going to be plugging 0 into our function. So the way that we're going to do it is we need to figure out a couple derivatives. So first we're going to start off with f of x, which gives me e to the x. Take the first derivative, I still get e to the x. Take the second derivative, I still get e to the x. Take the third derivative, I also get e to the x. So no matter how many derivatives I take, it's always going to be exactly the same. Now what we're going to do, let's figure out what f of 0 should be. So you're going to have e to the 0, gives me 1. F prime of 0, okay, it's still going to give me 1. F double prime of 0, still same thing, gives me 1. F triple prime of 0 still gives me 1. So that's a good thing about e to the x. You're always going to have really nice numbers. It's just going to be the same as long as you don't have something in the inside of the x. But we'll do one where it's not going to be as easy. But this is basically what you want to be able to do. So now all you want to do is just plug it into the thing that I just underlined. So my function f of x is going to be equal to, so f of 0 equals 1. So I'm going to plug in 1 in there. F prime of 0 is also another 1 over 1 factorial and then x. F double prime of 0 is going to also give me a 1 over 2 factorial x squared, and then keep going 1 over 3 factorial x cubed, continues on. So this is basically the Maclaurin series. Now we want to go ahead and just have some sort of general form. Okay. So now notice that this x to the n stays the same. Nothing's really happened to that x to the n, this guy. Nothing's happening to the n factorial. Now can we come up with something that's going on with the derivatives? Well, the derivatives are always going to be the same. They're all just 1, no matter what. Okay, so we're just going to plug in a 1. So basically, my whole series is going to be from 0 to infinity, x to the n over n factorial. So I can go ahead and describe e to the x at a equals 0 with this particular function, okay, or with this particular series, okay. So that's basically what you want to be able to do. You want to work with this part in the right hand side, and then expand it and try to find some sort of pattern, okay. Now this was just a Maclaurin series because you can easily make it into a Taylor series too. So this is what you want to do. So let's say, for example, you wanted to do this. So you want to find the Taylor series, okay, for f of x equals e to the x at a equals 2, okay? So let's say we want to find out that. Oh, we forgot to find the radius of convergence. I'll show you how to find the radius of convergence in a bit. Okay, I'll just put a little star here. Okay, so now we want to find the Taylor series. Okay, so what you want to be able to do to find the Taylor series, let's go ahead and first start off by writing out the formula, okay, for the Taylor series. So we know that the Taylor series is f of x is equal to the sum from n goes from 0 to infinity of f, the nth derivative evaluated at a, x minus a to the n divided by n factorial. So if I were to expand this, you're going to have f of a plus f prime of a over 1 factorial x minus a plus f double prime of a over 2 factorial x minus a squared, and then continues. So now what we want to do, well, let's start off with our function. F of x is e to the x. So when I take the derivative of this, you're going to get e to the x. I take the derivative again, you're going to get e to the x again, and so on. So when I plug in a in this case equals 2, not 0 anymore, now it's 2. So I'm going to plug in 2. It's going to give me e squared. Plug it into the derivative, I'm going to get another e squared. Plug it into the the second derivative, not the third. You're going to get another e squared. That should be a 2. It's going to be another e squared, and we continue on. So now we're going to plug all of these things in to this part. So you're going to have f of a, which is e squared. F prime of a is another e squared over 1 factorial x minus a is equal to 2. Then the third derivative, e squared over 2 factorial x minus 2 to the power of 2, and then so on. So now what we want to figure out is a general form for this. So you have the sum from n equals 0 to infinity. Notice that the derivatives, or these guys that I'm circling, they are always the same. It's always going to be e squared. So what I'm going to plug in here is going to be e squared. Always going to be e squared. Then you have x minus 2 to the power of n over n factorial. This is going to be the closed form of this thing. Okay? Instead of writing all of this out like this, you want to be able to plug it in here. Okay? Put it into a general form. Okay? Sometimes it's easy, sometimes it's not. And we'll do some problems where it's kind of difficult. Now let's go back and find the radius of convergence for this. All you really have to do is use the ratio test, because this is what e to the x equals to. So we know that e to the x, let me go back to the original, e to the x equals the sum from n goes from 0 to infinity, x to the n over n factorial. So all you have to do to find the radius of convergence is let's just use a ratio test. Okay, kind of very similar to how we were doing the power series. So we know that a sub n equals x to the n over n factorial, and a sub n plus 1 is going to be x to the n plus 1 over n plus 1 factorial. And I'm using the ratio test because we have factorials in here. So what you want to do is just take the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n. So we have the limit as n goes to infinity of a sub n plus 1, which gives me x to the n plus 1 over n plus 1 factorial, times the flip version of that one, which is going to be n factorial over x to the n. So we have limit as n goes to infinity of x to the n, x to the first. The bottom part is just going to be n plus 1, then n factorial. Then you have n factorial over x to the n, x to the power of n. So you can see that the x to the n's go away, so do the n factorials. I can take this x on the outside, absolute value of x, limit as n goes to infinity, and what I'm left with is 1 over n plus 1. And you can see here that this part, no matter what it is always going to be 0. So when I multiply x, it doesn't matter what x is, this thing is always going to be equal to 0. And 0 is always less than 1, so this thing is always going to converge. So the radius of convergence is infinity. Okay? So that's how you would do it, the same way that you would do it with power series. Okay? Now, sometimes what you're going to have to do is that you're not going to have these really nice, how do you say it? You're not going to have these nice derivatives where everything is just the same, e squared, e squared, e squared. You might have some other problems where you actually have to come up with or be a little bit more creative. So we're going to do one more in this video, and then we'll do more in the other one. So let's just do one more And let's say you want to find the Taylor series for now f of x equals e to the negative x, okay, about x equals -4, okay? So how would that work? So does the fact that I have a negative there going to change it? Well, let's see. Well, we want to figure out a Taylor series, so let's write out the Taylor series expansion for this. So what you want to first start doing, let's start off by writing f of x is equal to the sum from n goes from 0 to infinity of f n a x minus a to the n divided by n factorial. Okay, remember that this is just f of a plus f prime of a over 1 factorial, x minus a plus f double prime of a over 2 factorial, x minus a squared, and then we continue. So we're going to start off with f of x. So f of x is equal to e to the negative x. I take the derivative of this. Now it's not going to be just e to the negative x. It's going to be negative e to the negative x. Then do it again. Take the second derivative. And I'm going to have positive e to the negative x. Then I take the triple derivative and have negative e to the negative x. Take the fourth derivative. Then I'm going to have positive e to the x. So you can kind of see this, okay? And then all we're going to do is plug in x equal, oh, this should be a. Well, a equals -4. So now what we're going to plug in, we're going to plug in -4 in here. So f of -4, that's going to give me e to the -4. Then f of prime of -4, that's going to give me negative e to the -4. Oh, this should be +4. Then f double prime of -4 is going to give me e to the +4. F triple prime of -4, you're going to have negative e to the +4. And then the fourth derivative of -4, you're going to have e to the +4. Okay, so you can kind of see that you have some sort of alternating series here. Okay, where you're going back and forth, you go positive, negative, positive, negative. Okay, so let me go ahead and plug it into my Taylor series in this guy. So f of a, we got e to the 4. Then we got f prime, that's negative e to the 4 over 1 factorial, x minus -4, which in this case is going to be +4. Then plus e to the 4 over 2 factorial, x plus 4 to the second power, plus negative e to the 4 over 3 factorial, x plus 4 cubed, and then we continue. Okay, so now what we want to do, we want to find the general form. Now, basically everything's going to be the same except this part. Okay, so we're going to have the sum from n goes from 0 to infinity. So what's changing? Well, you have an e to the 4 regardless. You can see that the e to the 4s are always going to be the same. So you're still going to have e to the 4. You're still going to have an x plus 4 to the power of n, and you're going to have this n factorial on the bottom. But how do we account for the fact that the sign is changing? Notice how it's positive, then negative, then positive, then negative. So that's an alternating series. So that's a -1 to the power of n, because n starts at 0. So this is just going to be positive. Okay, and then when I plug in 1, it's going to be negative. So this is going to be the full Taylor expansion at a equals -4.